We hear it all the time, right? Artificial intelligence is going to solve some of the world's biggest challenges, from curing diseases to stopping financial fraud. But there's a huge catch. The most powerful AI needs the absolute best data. And our best data, our medical records, our financial history, well, that's also our most sensitive. So how do you fuel all that innovation without wrecking privacy? The answer, surprisingly, is to use data that's, well, fake. And this is the fundamental question that's really shaking up the world of data science. On one hand, you've got these incredible AI models that can spot patterns a human would never see. But on the other, you have this non-negotiable need to protect people's personal information. For the longest time, it felt like you had to choose. You could have progress, or you could have privacy. You couldn't have both. And that right there is the heart of the AI data dilemma. We're sitting on these mountains of incredibly valuable, real-world data that could train AI to do unbelievable things, but actually using it is like walking through a minefield of legal, ethical, and security risks. So, what's the way out? Okay, let's break it down. You can see the trade-offs are super clear. Real data, that's the ground truth. It's the real deal, it's perfectly accurate, but it comes with massive privacy baggage. So enter synthetic data. This stuff is artificially generated by algorithms. The whole point is to mimic the statistical patterns of the real data, but without containing any of the actual sensitive info. It's designed to be useful enough for training AI while slashing those privacy risks. So what is synthetic data really? I absolutely love this analogy. Think of a master food scientist trying to recreate the secret flavor of a famous soda. They don't steal the formula, no way. Instead, they analyze the original. They figure out all its components and how they work together, and then they build a brand new version from scratch that tastes exactly the same. They've captured the essence of the recipe without ever laying eyes on the secret recipe card. That's precisely what we're doing, but with data. Now, of course, you can't just push a button and get perfect, safe synthetic data. It's not that simple. Creating high-quality fake data is actually a really rigorous process, because if you mess it up, the data is either totally useless for training AI, or even worse, it's not actually safe and can still leak private information. So how do you get it right? Well, it really comes down to a structured 5-step approach, like this one laid out by Singapore's Personal Data Protection Commission. First up, you have to know exactly what you're trying to do. Then you prepare the source data, cleaning it up and pseudonymizing it, which is just a fancy way of saying you swap out private details with fake ones. Step 3 is where the magic happens. You use a model to generate the brand new data set. But you're not done, and this is key. The final steps are all about assessing it for privacy risks and putting controls in place. This makes it a really disciplined engineering process. And look, this isn't just some academic idea. It's happening right now. JP Morgan, they use it to train fraud detection models on really rare events that you just don't see much in real data. Johnson & Johnson uses it to share sensitive clinical trial info with researchers all over the world, which helps speed up medical breakthroughs. Even MasterCard uses it to check its AI models for fairness and bias without ever touching real customer data. It's already out there, solving huge problems. But just when we thought we had this all figured out, a new technology exploded onto the scene and basically changed all the rules. Generative AI. The very same powerful models that can write incredible poetry and create images that look real, well, they present a completely new and much trickier set of challenges. There's this saying called Goodhart's Law, and it just perfectly captures the new problem. For the older AI, our measure for good synthetic data was pretty simple. Did it match the original statistics? But with generative AI, just being statistically similar, that is not nearly good enough anymore. If that's all you're aiming for, you're going to miss the much more subtle and frankly more dangerous ways these new models can fail. Think about it for a second. A large language model doesn't just spit out numbers in a spreadsheet. It generates language. It summarizes. It creates. It makes inferences. And because its outputs are so creative and complex, they can go wrong in ways that are way harder to catch than a simple statistical error. The old rule belt? It's pretty much obsolete. And the stakes, they couldn't be higher. Especially in a field like medicine. We're seeing totally new types of failures. An AI can hallucinate and just confidently invent a symptom a patient never ever had. It can make an omission, leaving out a critical drug allergy from a hospital discharge summary. It can disrupt the whole narrative, completely scrambling the timeline of a patient's illness. These aren't just little bugs. These are potentially life-threatening mistakes. So, this new, way more powerful AI demands a new, way more sophisticated way to check its work. We need a whole new playbook that goes way beyond simple accuracy and starts measuring what actually matters in a high stakes place like a hospital. This means we have to fundamentally shift our mindset. The old question was, is the output statistically accurate? The new question is so much deeper. It's, is this output safe? Is it fair? Is it actually useful in a real clinical workflow? Is it helping or hurting a doctor who's trying to make a critical decision? And to answer those new questions, we're seeing frameworks like the 7Cs pop up. This one's from the US Food and Drug Administration. See, it's not about one simple metric anymore. You have to check for congruence, how well it aligns with real data. But you also need to look at coverage to make sure it represents all kinds of different patients, constraint to make sure it follows basic rules of biology, and of course, crucial things like completeness, compliance, and consistency. It's a full 360-degree quality check. And other new frameworks are taking it even a step further. They're not just finding errors, they're classifying them based on their potential to cause real-world harm. They're creating a risk score for different kinds of mistakes, which lets doctors and hospitals focus on preventing the most dangerous failures first. It's a huge shift from just finding errors to actively managing risk. When you boil it all down, this whole thing, it comes back to one word: trust. We can build the most powerful AI in the world, but if doctors and patients don't trust it, it will never live up to its promise. And building that trust, well, that's a complex, multifaceted challenge. What we're seeing is a move away from this simplistic single metric, let's test in a lab once view of AI quality. The new way is multidimensional, it's continuous, and it balances pure technical performance with these very human ideas of trust, fairness, and real-world usability. It's kind of like we're evolving from pure engineering to more of a socio-technical science. And that makes sense, right? Because trust isn't just a technical specification you can code. It's a social contract. It means you have to get everyone in the same room: the patients, the clinicians using the tools, the regulators who make sure it's safe, and the developers who build the models. And you have to get all their priorities aligned. Without that teamwork, even the most amazing technology will fail to find its place in the real world. Which leaves us with this final, really fascinating question. For decades, we've been trying to make AI more human-like in what it can do. And now that we're faced with the complexity and the risk of that success, we're being forced to evaluate it with more human qualities, a focus on safety, on fairness, context, and trust. You have to wonder, maybe as AI starts to mirror us, we're finally learning that we need to measure it in our own image.